So let's solve this question. This has once again been asked in UGC NET 2017. We have been given a set of Java programming statements and we are asked to find the output. So remember, whenever you're asked to find the output of a code snippet like this, you should always start from the main method. Why? Because main is the starting point of execution. Any program or any file, or let's say, any Java programming file or any class that you would want to execute must contain the main method. A class may exist without the main method as well. It is not essential for every class to contain a main method. Classes without the main methods must depend on other classes for their execution. So whenever we are asked to trace the output, we should always start from main. Now we can see that main has only one statement. What's it saying? It's saying system.out.print. That means print the following statement. What is it? It's first. And what is first? First is the name of my class. First.cbse, and the argument that is passed to this method called cbse is 60. Now this may seem a bit peculiar at first because a method is being invoked with respect to a class. So method is being invoked on a class. Now is this possible? It's very much possible because cbse, mind you, is a static method. Now all static methods, remember, belong to the class and they are shared by the objects. Since static members, that means static variables as well as static methods, are class variables or class methods, they are called on a class. That's why we have first.cbse of 60. There is nothing wrong with this statement. Had this static qualifier not been present, then we could have invoked the cbse method on an object. Anyway, now see, when this call is invoked, that means the cbse method is invoked with an argument of 60. So this 60 will get copied to x. So x now has a value of 60. Fine. So far so good. Now coming to this method, coming into the body of the method, we find a condition. What is the condition telling us? It is telling us to check whether x is less than 100 or not. Yes, it is less than 100. Now, since this condition is satisfied, this statement will be executed. Now, this statement is again calling cbse. So, the function is calling itself, and such functions are known as recursive functions. So, in order to trace the output of this function, we need a data structure called stack. So, how does a stack operate? A stack operates using the last in first out principle. That means the last element to be pushed onto the stack is the first one to be popped, or the first element to be pushed onto the stack is the last one to be popped. So in order to find the output of this function or this method, we need to make use of a stack. So I'll show my stack horizontally due to lack of space. Remember, a stack can grow upwards as well as downwards. Whatever implementation you assume, please stick to one. Do not change your implementation method in between. Anyway, now let's trace this output. Now x is 60. So we have a call of cbse 60. Now, this cbse 60, okay, I'll write this in a better way. I hope it's visible now. cbse of 60 will invoke, cbse of 60 will invoke cbse of 70, right? So, and now remember, after this invocation completes, that means cbse 60 invokes cbse 70, where should it continue? It should continue from return. So, I'm writing that over here, R. That means after this statement executes, that means cbse of 70 executes, the next statement that this method must execute is return x minus 1. So I've written R. This is the point where it should resume its execution. Now cbse of 60 will lead to cbse of 70. Now, with CBSE of 70, what we get, again, the condition is satisfied. CBSE of 70 will now call CBSE of 80. And on return, it will execute this statement. So, CBSE of 70 invokes CBSE of 80. And CBSE of 80 again satisfies this condition and in turn invokes CBSE of 90. And once it returns, it will execute this statement. This statement on the return value. That means the value that CBSE of 80 will get from CBSE of 90, it will return that value by subtracting 1 from it. So CBSE of 80 will invoke CBSE of 90. So CBSE of 90 is invoked, and again it will execute, or it will continue its execution from the return statement. Now observe this, CBSE of 90 will invoke CBSE of 100. Now once it invokes CBSE of 100, this condition will not be satisfied because 100 is no longer less than 100. 100 is equal to it. So this condition will not be satisfied and we will not be able to execute this statement anymore. So we'll come to this return statement. What is this return statement telling us? This return statement is telling us to return x minus 1. That is 100 minus 1, that is 99. So this will return a value of 99. So this has been popped from the stack. This activation record or this function call has been popped from the stack. That's why I've crossed it out. And it has returned a value of 99. It has returned a value of 99 to whom? It has returned a value of 99 to CBSE of 90. Why has it returned it to CBSE of 90? It has returned to CBSE of 90 because this was the function that had invoked CBSE of 100. So it is the duty of CBSE of 100 to return the value to the calling function. So the calling function in this case was CBSE of 90 and the called function was CBSE of 100. So the called function returns to the calling function, and in this case 99 is returned to 90. So what will CBSE of 90 do? It will simply return the value that it received to CBSE of 80 for the same reason that I explained for CBSE of 100. And now this pop operation will be, it will take place one after the other. So we'll have a series of pop operations. This will return a value of 97. See, it's always returning x minus 1. It is receiving 99, it is returning 98. Receiving 98, returning 97. Receiving 97, returning 96. And finally, CBSE of 60 will return 95. To whom? To the function that had called it. And who had called CBSE of 60? CBSE of 60, mind you, was called by main. So main gets a value of 95 and the final output that we get is 95. I hope this made complete sense. Thank you.